episode of skill development program of KIC HIT Idea Lab. So, you will know a lot more about what is Idea Lab and how it can impact your day-to-day life as a student, what you are thinking, how you can practically implement those kind of things in your branch. Okay, so all of this, our experts, our interns are there. So they will introduce to all of them. So let us introduce our interns. We have Mr. Amar Rako, Officer of Special Duty, Eye Care Room with us. So I'd like to invite Professor Murmur from HOD Technical Care Department and the coordinator of we have among us Professor Tarun Gandhi Jana, Dean, School of Engineering. I would like to request the professor to kindly felicitate the co-coordinator of SKDL to kindly felicitate We also have with us Professor Priya Shah from the Department of Biotechnology. I request Professor Ghosh to kindly felicitate her. We also have Professor Shambhu Chatterjee from Biotechnology Department. I request the professor to kindly felicitate. Yes. So before going into the actual session, so here we will hear from our the expert opinion from our dignitaries. So they have experience in this field for so long. Their views, you will also get to know about the evolution of the Idea Lab, its movement, how it can impact your life. So without spending much of time, I'd like to invite Mr. Amar Rako, Officer of Special Duty, Eye Care Room, to elaborate on this.
Thank you. Thank you very much. Good morning to all of you present here. And with due respect to Professor Jana, Professor Gautam, Professor Ghosh, and faculties of Biotechnology Department, and this is present here. This Idea Lab, the very thing is Idea Lab is a lab where you transform your ideas into some kind of organic, some kind of a tangible product, which we call a prototype, and whose behavior you can observe. So when you talk about Idea Lab, the idea is here. The idea comes here first. So first laboratory that you have is you yourself. Every engineer or a budding engineer who is studying engineering and would be engineer tomorrow, would be serving the industries, whatever any kind of industry or a service sector, will definitely be associated with some kind of a production, some kind of a economic goal or some kind of a service, and so the things will have to first get generated. Every engineer first that is so first try to first appreciate your idea and first is your mind, your own knowledge, whatever your mind starts observing, whatever you are moving around, whatever you are seeing around, and from there you can generate a lot of ideas. Then what is this Idea Lab? Now they will explain to you better what I have seen in the last couple of years of association with IT and there. Whatever ideas, this Idea Lab is encouraging you to develop ideas here and verify your ideas with certain physical products happening at the idea. So this Idea Lab is going to help you. When I am thinking a lot of things coming into my mind, but what I am going to do, I cannot see what is really the outcome of my ideas. You want to see the outcome of your ideas. So first, my only thing I will do is like keep generating ideas, keep observing things around you, keep knowledgeable. Like what you learn at the very basic. Newton saw some apple falling and the science getting developed. That's the ideas started getting developed from time to time. Kept on improving. So a lot of things what people observe in life, seeing what from there they started thinking. So keep observing, and from their observations, develop idea in you. And this idea lab is practically is your own lab. It's not nothing, it's not some kind of a lab, where you need there are a lot of protocols to really to approach that particular lab very carefully. You can approach your clients and the process. So my only thing is develop idea here. Look at things, develop idea here, convert your idea into the idea lab. And how you are going to convert your ideas into an idea lab into some kind of a tangible product will come out of this workshop. These faculties and other trainers will train you up. And I wish all the success on this particular program. And I will request the honorable faculty, Professor Host, Professor Jana, Professor Chandra, to speak more about this idea lab.
Thank you, sir, for elaborating the importance of idea lab and idea exploration and validation. So, on this topic now, I'd like to invite Professor Jana to say a few words.
Good morning. Respected Mr. Amol Kapoor, Professor in Charge IDEA, Dr. Piasau, Dr. Sankar Chatterjee from Biotechnology, Professor Gautam Ghosh, Faculty of Mechanical, Professor Devdutta Ghosh from VIE and IAPC in charge. These two faculty members are acting as the nucleus of this idea lab. Whatever facilities, whatever developments and credentials that we can enjoy, the credit goes to these two professors, other faculty members, and of course the students of biotechnology. Mr. Gupta has already explained that in the current days, we should not be complacent with our day-to-day work, which are rather very stereotyped activities. If you want to survive in this global competition, you have to innovate. Keeping that in mind, AICTE has launched this particular idea lab, and fortunately, HID Haldia is one of the recipients of this prestigious idea lab. And this lab was developed roughly more than 1 year back, and since then, quite a good number of different programs involving faculty members all across the institution, and the purpose has been organized very successfully, and this time it is for the biotechnology. The IDEA is acronym. This acronym stands for Idea Development, Evaluation and Application. I don't know whether this sort of subjects are coming within the scope of biotechnology engineering, but still, this concept of the idea is very much akin to any engineering. Whenever any idea or whenever you think of any product or any service, we have to come up with some idea. Apparently, it may seem that these are fictitious. It may not be possible to implement. But through brainstorming, you generate some ideas. You conceive those ideas. Then, through step-by-step procedure, try to incubate or try to develop the idea. But it means a lot of problems will be coming up, and you have to get it or you have to think of how to eliminate those problems and can come up with a feasible solution. And this is not only confined to mechanical or instrumentation or electronics. Fundamentally, the equipment which you have in the idea lab pertaining to electrical, electronics, mechanical, but there is as such no restriction that people of biotechnology or food technology cannot participate or cannot use those equipment or instruments. Another important thing in the 21st century that study is no longer confined to a particular discipline. Although you have your core papers, your core fixed papers, or compulsory electives, and also open electives are there. So under these circumstances, you can select a particular paper if you have a keen interest, which is wide apart from the biotechnology, but it has got immense application or immense importance in your domain. Maybe machine learning, maybe artificial intelligence. So in the under these circumstances, even our government of India, with the national education policy 2021, you are aware of it. There should not be eventually there should not be any part. So we can have some major from biotechnology, some minor from the other discipline. So in that case, I would suggest that you open your mind, whatever facilities are available at our disposal in the Idea Lab, you explore those facilities. Some right idea may come up in your mind. Through your friends and under the guidance of the faculty members and the staff, try to develop something so that you can have a flavor of developing something new. And since the term it is laboratory, that is also a part of the Idea Lab. Apparently, in the sense that whatever laboratory courses that you undergo by virtue of the course curriculum, there are certain stipulated syllabus, some stipulated experiments, but here there is no such part. Any idea you can terminate and you can give a step so that you can test the flavor of doing something by your own hand. I welcome Principal Sir to this inaugural session of this idea program on the 3D printing and 3D scanning. So this the idea 3D printing, 3D scanning is very modern and state-of-the-art technology. Professor Bose is responsible. He has got a wide expertise of developing lot of products by using this state-of-the-art facilities which is available at our disposal in the Idea Lab. You know the 3D printer, if you go to the even in the present days, as far as the biotechnology domain is concerned, in the medical science, a lot of artificial limbs are developed through this 3D printing and the 3D scanning. So I feel those are the areas which will give you the immense interest as far as this 1 week long program is concerned. So without any further elaboration, I wish that this particular body program will be extremely beneficial for you and you will feel a difference and it will be highly interesting. And after completion of the year, you will be much enriched and in the coming days, you will carry forward your idea by using this idea. Thank you very much.
Okay, so before moving further, let us welcome our Principal Sir, Dr. Shubhadip Kumar. I'd like to request Dr. Jana to participate here with the presentation. So we'll talk to here for our Principal Sir about this program and how it can impact our students.
Good morning to all of you. Secret pleasure that our AICT Idea Lab Authority is going to organize some training to our other department people, students, our students. Today, you are the biotechnology students, so I know. But we have come here on the platform of AICT Idea platform. So, do you know that what is idea? I think many times we discussed that idea means idea, D means development, E means evaluation, and A means activity. So why AICT Idea Lab comes? How? So AICT has launched this program, rather this platform to encourage the students as they are getting interest on the engineering. I think STEM, science, engineering, technology, and mathematics students to get fundamental knowledge as well as hand-on training and some skill on the recent centuries development to enrich yourself and get you are able to produce some idea to I think prototype. So that idea you have to list. Then as we can do that from idea to prototype, and it's a hands-on training. So they will definitely guide you properly, and you will be benefited. And others who are expert on this line, they will always use you. If you have any questions, then you will ask them and make yourself as you are so skilled, because their hands-on training and learning by doing something. This is the main idea, because when you will see, but you will forget. But when you do, you will never forget. So this is the main idea of the AICT Idea Lab, and the people who are engaged here, they will guide you and success this program. Thank you.
Thank you, sir, for nicely explaining the importance of Formula and this program. Now, I would like to invite Kiara ma'am to share with you.
Good morning, everyone. Respected principal and official teacher of the official and all other individuals. I'd like to share some words regarding why we are interested for our students to give one scope to learn the AICT Idea Lab. The last year, this team, AICT Idea Lab, organized a faculty development program for our biotechnology students. That's time we participated in this program and we learned lot of things and we are enjoyed too. That's time I have an idea to give you one scope of our students. Now this is the first grade of our second year student in our biotechnology department. We go to the professors, doctors and Goshen to give them one scope for our students. In a one course, we are very much fortunate they accept our proposals, and that's why we are very much obliged the AICT Idea Lab team. Now, you know the biotechnology is not a only biological science. There are different engineering fields. How involved the different engineering fields you can learn in this Idea Lab. The AICT, you know the 3D printing nowadays. This is the we can say this is the era of 3D printing. How this 3D bioprinting can involve in our biological science. That can help you in tissue engineering. You can make a cell and tissue just like a living cell. And you can go to the nanobiotechnology, material science, and research and development, and also the drug development. That's an idea I can like to give you one scope that you can match the biological science and other engineering fields. Hope you will be enjoyed a lot, and thanks to organizing team and for
Thank you, ma'am. From the part of organizers, we can say that if you can show half the enthusiasm and energy that Kiara is showing in his program in her time in the last year, it will be fruitful for you and will be very satisfied. So now, I'd like to request Professor Shamusa, please say something about this.
Very good morning to all of our visitors to class, the principal sir, Dr. Jana, Professor Kaustubh, Professor Bush, and Sir Muslim. And good morning to all of you also. So we were here basically for AICT Idea Lab, and the topic that we presented over here is on 3D printing and 3D scanning. Okay, so today, as you know, that we are in a kind of fusion engineering generation. What a single subject can flourish in a kind of full mode. So we have to play in a kind of fuse mode. Why I am saying like that way? Because if I am taking the topic within 1 year, like 3D scanning or 3D printing, so you do know that this particular topic not only being like presented in a kind of mechanical engineering manner or production engineering or civil engineering or any sort of thing, but also you can better employ it in your sector as well. from biomedical engineering to organ printing. I do hope that all of you are well versed with the organ printing part. Okay, so if you are learning this particular technology in future science, you are basically employing it for organ printing purpose as well, artificial heart, artificial kidney, all those sectors. So if you will better learn from all the sessions that will be depicted by the previous officers over here, and then support tech gurus who will teach you in a kind of better way. So if you will learn it in a kind of better way, then you can grasp the technology of the future users. So I wish you all the best for your future sessions and have ethics utmost over here. Okay, so that's all for the session.
Thank you, sir. We are almost at the end of our conversation. So I'd like to add a few points to what Shamos has said. That please try to connect whatever you are learning in this program with your curriculum, with your subject. Okay, so 3D scanning and 3D printing. So 3D scanning means you get a bunch of point cloud. So draw parallel in your subject whether there are some techniques where you get a bunch of points and predict the structure in the competitive environment. And also 3D bioprinting is one very cutting edge research in this field. Also, I like to, if you do not know, like to ask you to search 23 Meet upcoming technology, okay? Using 3D bioprinting with the practical application of it in your field. Okay, so apart from that, there are other applications. So I just leave it to your imagination. You have to connect the dots. So now I'd like to invite Professor Devdutt Ghosh, co-coordinator of AICTE Idea Lab, to conclude the session.
Good morning. So, let me welcome Professor Dr. Subodh Mongul, our principal, Professor Dr. Tarun Jana, Dean, School of Engineering, Mr. Amal Dr. Officer of Special Duty, ITF, Dr. K.R. Saru, and Dr. Shamil Chatterjee. I welcome them once again to grace this occasion. And formally from the Idea Lab, I welcome you students. Probably this is the first day of second year, right? So we are lucky that you are starting with the movement, you are getting associated with the movement. Why I say so? Because this is not a laboratory. What AICTE says is a movement, it's a technical movement with the help of Educational Institute throughout India. They have started this movement where they have been coming up with the 21st century skills along with the facilities where you can train yourself and you can know, you can give the forum where your idea can be converted into prototype. A sort of, you can say, pre-incubation. So it may happen that from your pre-incubation level, you can have your own incubation. In addition to this Idea Laboratory, we have introduced one incubation center, though it is related to the Ministry of MSME. But if you are interested, if you get that kick in this particular training program, definitely you can have your own incubation. That's the idea. So in this Idea Laboratory, what we have, just if you visit, you will see that in a better way. We have some sub-laboratories within this. One is 3D scanning and 3D printing, which is the main subject of this skill development program. It has a woodcutter router, it has milling machines, it has embedded system. Broadly, these are the areas where we train the students, we train the faculty members. Not only we are confining ourselves within this institute, we try to reach out to school students, school teachers, industry, ITI students, etc. And from Idea Laboratory, it is our duty to spread the awareness, to train the people, so that many of the aspirants can come forward and can get the training and can go for
incubation finally, because we have huge population in our country. So everybody seeking for job, then there will be a imbalance. So you need to be job creator also. I do not know much about biotechnology, but what I gather from that, there are enough scope where you can use your domain knowledge and you can add on with this 21st century skill which you are going to get, and you can have a fantastic product or services which you can offer to the society finally. In this laboratory, in the embedded system, we are trying to touch upon Industry 4.0 is a small way, along with all testing facilities for developing printed circuit boards. We have Internet of Things. Internet of Things, I believe, can be used for any branch of discipline. So, if time permits, definitely within this particular skill development program, we will try to give you little bit of emphasis on that area also. Before I end, let me introduce along with us, Dr. Gautam Ghosh is the coordinator and the co-coordinator. We have four technical gurus who will be interacting with you during this skilling program. Then we will introduce Dr. Siru Banerjee and Dr. Siru Rai, Supriyo Rai, sorry, and Dr. Ashim Haldar and Dibyendu Chaudhary. And I must introduce another persons who will be also associated in the training program, Mr. Shomen Rai and Shantanu Vaidhi. And of course, I should not forget the name of Mohan Pantro because silently, behind the curtain, he is always working to make this kind of program successful. Thank you very much. At the end, I also appreciate the student members of this laboratory, and it's my appeal that at the end of the skilling program, since your name, you have a ID in the ICT Idea Laboratory, we get some effective members for the Idea Laboratory for the future. Thank you very much.
Thank you, sir. For skilled professionals can have information, have knowledge, but you are not a skillful person, that will not lead you to a great extent. Now, what we have thought of, like students should be skilled. It is mandatory for students to have certain skill set which will help them to excel in life, whether higher studies or job or any entrepreneurships, whatever you do, you require skills apart from knowledge. So in this Idea Lab, we'll be giving you certain skill set so that it will add to your CV. With this skill, it will be helpful for you to gain hands-on experience. We believe in knowing by doing. If you are working on something, if you are using your effort, it will not only help you to learn but also to acquire experience. Right? Think of those days. How many of you, by the way, know cycling? Riding cycle, bike. All of you. How many of you know how to swim? Okay. So what was the first experience while swimming? You took a lot of water, right? But slowly, you know how to float. Then slowly, you know how to move forward, right? So that is the skill. Well, I can teach you through my slides,
What is the best thrust you can apply with your hand? How you can paddle while floating? Mathematically, I can give you all the information. Then I take you and put you on a pool where you have every knowledge. You know the mathematics, you know the force, you know the angles. Do it. Can you do it? For cycle also, I can tell you how to balance. What will be the center of gravity? What will be the load? What will be the friction on the road? And I put you on a bike and I tell you when you ride. Can you do it? By the way, the first time you were on a bicycle, you fell off. Right? But slowly you knew how to balance. Same thing goes for kids who are toddlers trying to stand. They fall number of times, but still he or she doesn't give up. It's the will to know the art of standing. We all did. Right? So that's the skill. The skill to stand on your own feet. So skill is without skill you cannot move forward in life. So basically today I will be teaching you. So the thing is like the theme of the skilling program is basically 3D printing and scanning. Well, these are the very two common names I think you have heard a lot of times. 3D printing is basically making a prototype out of a drawing. Right? You have a CAD drawing in the CAD domain. CAD means computer aided design. So you draw in a computer and you make it any product. Okay, very simple. So that is a CAD drawing you have to make using certain softwares, and then you interface with some machine and it will print for you. Just like your machines are connected with a printer, you pick any drawing from Google and you want to print it. So it is as simple as that. And second is scanning. So with the mobile nowadays you scan images of writing or figures or whatever. Right? So that is also scanning Adobe you use, right? So with that you scan and you take the impression or image and you print it. So the technique you know, but this is on a bigger scale. The technique you know is on 2D platform, because you're scanning image of a paper or an impression and you're printing on a paper of an impression. But is it an impression? Because if you go to a nanoscale, there are small heights of alphabets, right, on a paper. We neglect it because of the small height. But that means a 3D printing. Okay. So we know the stuff. Let's see in details what are the things like. So this additive manufacturing is another name or acronym of 3D printing. So why additive manufacturing? Because it is addition of layers. When we are adding layers to build certain object, so it is called additive manufacturing. Just like your buildings, it is built on layers, right? Layer after layers of bricks are piled and then the whole structure got built up. Books, you have layers of papers and it got the volume. Right. So this is what additive manufacturing is like. We add on layers of materials and we give the entire structure in 3D form. In contrast to what we have seen in subtractive manufacturing. In workshop you might have seen lathe or carpentry. By the way, you have done workshop. So over there, you are removing excess material, right? In carpentry also with a chisel and hammer, you remove the excess material and you give a shape. So that is subtractive. You are removing material and you are giving a shape. individual. Just like your in biology, you have single cell and it's adding multiple cells to give a shape. So from single cell, you are adding cells or cells are added, and an entire human being or a plant or any living being is created. So these are the contents basically. The 3D printing, which is basically known as stereolithography. Lithography is 2D. Stereolithography is 3D. Okay. The term lithography is 2D printing or image. Stereolithography is 3D printing or 3D image. Okay, so 3D printing is basically stereolithography. And additive manufacturing, it can be also known as additive layered manufacturing because layer after layer of materials are added, or additive digital manufacturing since this addition of layer takes place in the digital platform. Addition of layers takes place in the digital platform. How? In the CAD platform. Okay. So CAD, you know CAD.
Some examples I have shown: NCCNC machine, robotic system. CMM is for measurement. We call it coordinate measuring machine. That is not for cutting, but for taking the measurement. Also based on the software. So, what is the basic principle of this computer numerical control? For computer numerical control, the concept came in a very humble manner in the form of only numerical control. The computer numerical control (CNC), the first C was omitted in the initial form. That means the concept of numerical control came into existence in 1956 at MIT when there was no computer. Only thing is that, as I was giving the example of the conventional machines, those machines were initially controlled by electronics components or electronics hardware in the form of numerical control. What is numeric? Well, we are talking about this software program. So in this eternity, you have to write different codes. Those codes are basically combinations of alphabets and numericals. There will be some character A, B, C, D, E, Z up to Z and 0 to 9, and in some cases some symbols may be there. So generally we call it alphanumeric. Alphabets are there and numerics are there. So these combinations of different alphanumeric codes are responsible to carry out different cutting tool movement and other auxiliary functions which are required to carry out cutting operations or basic operations. So in a humble way, so according to EID, it is a system in which actions are controlled by the direct insertion of alphanumeric data, which generally called codes. At some point of time, the system must automatically interpret at least some portion of the data. While it is to some extent incomplete data or incomplete statement, last one, the system must automatically interpret at least some portion of this data. Because of the fact it was under development stage. Today we have got certain level of achievement. Maybe research is continuously going on. So maybe after 1 year some additional development will have taken place. So those are also implemented. Likewise, there is as such no restriction. Only thing is that the control actions or the movement will be accomplished by some alphabets and numerical. Generally called alphanumeric codes or simply numeric code. That is why it is called numerical control. And also you focus your against cycle term control. That means we are only interested not about the actuation. Same control is there. Maybe a different type of control for better performance, but the major thing is on the automation. That is the control of the decision making. So decision making part is taken care of by the alphanumeric code. That is what exactly the NC. So the data required to produce a part geometry, in our case, you would like to develop, say there will be a long slender bar, maybe steel bar, but through cutting, you have to generate a shape something like this. Okay, so that is our objective as far as machining part is concerned. That is why this particular part geometry are generated following a definite syntax. The program that will guide it must have a definite syntax. It cannot guide anything other, whether it is C programming or machine learning or whatever it may be. There must be certain your syntax. So that syntax you have to follow. And of course, it should all the codes should appear in the logical manner in a suitable medium. At that time, there was no internet. So, old type of punch paper tape was utilized to create or to store the part program. That is a very tedious type of system. But what I am talking about in the 1960s. So, at that time, you have to think about what would have been the alternative method. So, punch paper tape was the means to store the part program and to keep the data by the machine control unit afterwards. So this is what exactly as a whole we call it as a part program. A part program includes toolbar, process variables, and auxiliary functions. I don't know whether you can recall your first year workshop classes. If you think of any classes on say lathe operations, okay, I am not asking or I am not telling you. Just recall the job was planned on a chart that keeps on rotating at high speed, and on this side there was a cutting tool. So this job keeps on rotating, and this cutting tool with some elegant made of depth of part used to trace the path so that your desired job geometry can be created. So that is the fundamental sort of very better. So from that perspective, a part program must include tool path. Now in your assume the conventional machine, this tool path is controlled by the operator. But in this particular case, this tool path generation will be taken care of by the part programmer, not the operator. Okay, so your part program must contain that tool path. Because it is a tool path, that is the cutting path, is the most crucial activities of the step generation. So the course should contain tool path, process variables. The process variable whenever any operation or activities take place. This may be equally applicable in your biotechnology domain also. If you want to carry out some experiment, there will be 2 or 3 or 4 some crucial parameters which you ought to regulate to get the desired result. It may be time dependent phenomena, it may be temperature dependent phenomena, it may be your what is called other illumination for the growth of the cell or something like that. So 3-4 parameters which are instrumental to control that particular process.
So today we'll visit embedded system but in a virtual way, because embedded system laboratory is having many instruments, many facilities. In 1 hour or 2 hours, it will be only possible to explain or demonstrate each and everything. So what we plan, we'll take a very small circuit. First we'll realize the circuit, very small circuit, which you can understand very easily. Then with the help of suitable software, we'll try to make it PCB compatible. Then we'll develop the PC according to the diagram developed by Eagle software. There is a software called Eagle. Then we'll develop the PC. And subsequently, put the components and we will test it. So that will be the journey. So what we have decided is, first we will go for circuit realization. I assume that you have studied electronics only in the first year, right? So I don't know how far you can remember it. So before we go for circuit realization, we have to talk about the components. We take a take one application as a reference. Right? So under circuit realization, we are going to realize an alarm system. It could be Wagner alarm system or otherwise. The circuit will be designed in such a way if there is any obstruction comes in the sensor cell, it is going to give you a sound alarm. Okay, very simple sir. Now, first of all, I need a source, light source. And this light source can come from a LED, can come from laser. So if you use laser, there is certain advantages. First and foremost advantage is it produces coherent light. And because of this coherency, here we put the sensor. So this is the laser source. And let's say this is a resistance, but it's a special type of resistance. We call it light dependent resistance. How it behaves when light falls, it offers very less resistance. And imagine if there is some obstruction, what will happen? So it will offer very high resistance. This is how it works. Okay? So you allow, as I told you, if there is an obstruction, it is going to generate the alarm. That is its function. Okay? So this is the sensing system. Though I am taking an example, this particular example can be replaced by other things also. Suppose there is a seismograph, but it does, it detects the output. Okay? So instead of this source, the signal which is being produced here, okay, will be similar to the electrical signal produced in the system. So that particular signal can be processed and you can generate an alarm or display, whatever you want. Basic logic goes in this direction. Now, the signal, suppose it produces a pulse, either this or this. Whenever an obstruction comes, it produces an electrical pulse, maybe positive, maybe negative, depending on the situation. Okay? And this pulse has to be processed in such a way that it can trigger an alarm. Clear? So what I do? I take this signal, this signal is supposed to trigger something, so I need a switch which will provide the supply to the alarm. Just let us understand logically first, then I will draw the actual circuit. So, if this pulse falls into a switch, but this switch cannot be a manual switch, because manual switch is electromechanical switch. You need a force in order to change the state, on off or off on, whatever. Switch has two states only, on or off, no intermediate. Here also you need a switch which will activate the alarm circuit. Okay? And purposes, sir? Another point. This is first point. So this pulse has to be processed or conditioned before it goes to the Alexa. Why this so? Because I told you it's a pulse. So duration of the signal will be very less. It depends on the obstruction. How long the obstruction is being provided. So let us take the worst situation where the pulse width is very, very less. Right? But your alarm duration should be little bit high. Right? If it comes once, you may ignore. At least it should buzz for 30 seconds or 1 minute, whatever, according to your comfort level, you can adjust it. So what do you do? After that, it will go to a circle where it will be processor condition and duration of alarm is to be enhanced. Do you agree? Simple. Clear? Now I said this will go to a switch. That switch will be automatic switch. And the base switch and cheapest switch is a transistor switch. You must have studied BJT, right? I'm studying BJT basically takes many things you have studied, right? Biasing, viewpoint, load line, then amplifier, many things. Let us not go into that complex picture. But let me tell you, transistor has a fantastic property. It can act as a switch. And this was the first automatic switch. Nowadays we do not use BJT switch much because there are many modifications happening. Alright? But still in this application we can go for a BJT switch. So what do we do? When pulse comes, it will give us signal either on or off. When pulse is omitted, it will give the opposite signal. And to be more precise, transistorized switch acts as a NOT gate. So when it receives high pulse, right, then it will give you 0. Right? And when this is 0, it will give you 1. Since it is a switch, there will not be any intermittent state. Either one or zero. I do not need anything. Either there will be obstruction or no obstruction. No other state. No partial. So I need a switch. Either alarm will buzz or not. Simple. So why is this happening? When you are giving one means a voltage you are giving. High voltage you are giving. Let's say 5 volt. In the form of a pulse. Right? Then transistor gets on. Transistor gets on means fully on. It's a fully on, 100%. 100% on means mentally you think that this is as if shorting. Not actually shorting, virtually shorting. That means this is the emitter side, we know, because arrow is given, NPN transistor. Yeah? So this is going to be shorted with this. Since it is connected to the ground, what will be the status of the collector? 0. Ground is 0. So naturally it will give you 0. When there is no pulse, transistor is off. So this should be a break circuit. So Current cannot flow through this, so it will receive that. So it has a reverse law. When pass is available, it will give you 0. Right? When pass is not available, it will give you high. Clear? Now your purpose is over. So what you have done is switching. I can give this directly to the announcer. But one job is still not executed. Which one? That duration of the pass. That is where. Then what I will do is I use a very interesting IC. Almost everybody knows this is a timer IC. I go hard this name 555 timer. Though it was not there in the syllabus, but many students, for the sake of their projects, they use it. This is actually a timer IC. Very interesting.